Okay, good evening, everyone. Um, those of you who came last week to the solar one, hi again. Anyone else, welcome. I've got a slide here just saying a little bit about who we are. We're a community benefit society, so we're a not-for-profit, and we operate in East Sussex. Um, and it says here, we're looking to tackle the climate crisis, but also energy injustice. So people who are paying too much for their energy. Typically, that is the poorest in society who are paying a higher proportion for their energy than other people. And we're trying to do that in a number of ways: community-owned renewable power and also energy saving schemes where we can. And frankly, our view is that energy advice of whatever description meets that requirement as well. We're helping people save energy. We're helping them decarbonize through this kind of event. Right. There we go. Right. Fundamentals. This is a little bit too much like physics for me, which is a number of decades ago. But okay, how does a heat pump work? Well, it doesn't actually do any heating or cooling itself. What it's doing is it's moving heat from one place to another. And every one of us has a heat pump in our house. If you've got a fridge or a freezer, I suspect that's 100% of households in the UK, then you already have a heat pump, something that is moving heat from inside the fridge to the metal sort of grill on the back to cool the fridge and put that heat into the rest of the house. So basically, the description is talking more about heating your house. So heat is captured outside using a pump and a compressor and then moved. Because it's not making heat, because it's actually just moving it, it can be more than 100% efficient, which sounds like magic, but it is just moving it. It doesn't fool any of the laws of conservation of energy or anything like that. And it can be up to, well, I said 300 to 400% efficiency. What that means is 1 unit of electricity can actually move 3 or 4 units of heat from outside into your home, or frankly, the other way. We'll talk about that later. You can get significantly higher. So there are people who are constantly pushing to try and get higher efficiencies than that. I know people who are getting 600% efficiency, but they have really worked very, very hard for that. For most heat pump installs, it will be 300 to 400% efficiency. And there are two main types of heat pump. Ground source, sometimes it can be water source as well, but the idea is you pipes underground, circulating a liquid through that extract heat from the water or the ground, and air source, where you have a fan outside, which I think is probably what most people think of when they think of a heat pump. It's a fan outside. And the heat can then be I just realized that says a bit of a spelling mistake there. Anyway, the heat is then transferred into central heating. So it can be radiators or underfloor heating and hot water, or a different type of heat pump. It can be blown around your home instead. Cover that. There's the whole how it works. It is quite complicated. It's all about allowing gases to expand and then compressing them again. I don't need to go into that. My physics has been sufficiently long ago that I would struggle to explain all of that, but it definitely does work. Right. So having said there's two main types, the ground source and the air source, really there's kind of three, because the air source splits off into air to water and air to air. I know that someone has already put a comment in the chat about one of these bits. So ground source, pipes circulate liquid through the ground, then that comes in and that then heats fluid that goes around through radiators or underfloor heating. And it can do hot water. It's going to do that. You will need a mains pressure hot water cylinder. Doesn't typically do cooling. Cover that slightly. It's complicated, and I'll go into why that is in a second. Ground source heat pump is extremely expensive, primarily because there's two ways that you get pipes going through the ground. It's either slinky hose, which is usually shallow trenches. So they excavate about 0.2 meters down. The trenches can be 20 to 50 meters long. And depending on the size of your house, you could have two, three, four more trenches required. So unless you have a very large garden and the wherewithal to actually have it dug up, instead you'll be going for boreholes, which is basically they will come and they put a massive drilling rig. The holes themselves will not be very far apart, very wide, but they typically are anything up to 100 meters deep. That is even more expensive than excavating for the shallow trenches. So we've put typical cost 20 to 30,000 pounds. Um, there is a grant, that will knock a little bit off there, but you can see proportionally it's not taking a great deal off there. And if you're on oil or LPG, then you actually get the grant is slightly higher. Um, then the one that I think most people will be thinking about, which is an air source heat pump that is air to water. So you have a fan outside, and then that goes to water inside, and that will either be radiators or underfloor heating. Sometimes a mixture of both. Again, it can do hot water. Um, Typically, that doesn't include cooling. The reason for that is because you run the risk of actually having condensation. So if you attempt to cool your radiator or your underfloor heating using the air source heat pump in summertime, you run the risk of actually getting condensation on potentially if you get it too cold on the inside, which can cause problems. If your underfloor heating pipework is buried, which it would be, you really don't want the pipes getting cold enough to have any kind of condensation forming, under your floor. So it is manageable, but it's very complicated, and most air source heat pump installers won't want to tackle that. So that's why we've said typically it won't do cooling. This is significantly cheaper, but it's still a lot of money. We think it's probably 10 to 15,000 pounds. That's the kind of quotes that we've been hearing from some of our clients. Again, you've got the £7,500 grant, or 9,000 if you are on oil or LPG currently. That's just come in, so that's a significant improvement for anybody who's stuck not on the mains gas network. That really can help make things more viable. And then the other kind of air source heat pump, air to air. So you've got a fan outside and then you've got a blower unit in each room. We will all have heard of this because it's air conditioning units basically do that. It will typically not do hot water. Really isn't something that I've heard of. You can get air source heat pumps that fit on top of hot water tanks, but I'm not going to cover that here. And they can definitely do cooling. That is significantly cheaper. I would say it was significantly cheaper because the grant has now come in at £2,500. I suspect that the prices are going to rise. I also think there's quite a lot of competition currently for the installers because of the third heat wave of the year that we're going through. So I think it's likely that installers will have been taking advantage of that slightly. So these prices may not reflect what you're now going to get, but certainly these were the numbers that were over the last few summers. Like I said, competition may have pushed that up. I also think the grant requires that installers jump through particular hoops. That is going to add additional cost to those installers. So anybody who signs up to the grant, as far as I'm aware, currently there are no installers who have yet been approved for the grant. And that is because the people who need to have approved those installers haven't yet released the training material required for the installers. So it's a bit of a chicken and egg situation there. The grant is coming. Currently, it's not there, but it will be. We've been told summer this year, but it feels like summer is currently upon us. So we picked kind of air source heat pump as this is the kind of typical thing that people will be looking at. It's the easiest one to do. Ground source, like I said, you either need a large garden or a lot of money or potentially both. So I think most people are going to see a fan unit rather similar to this. And then potentially a hot water tank, depending on what kind they get, and either radiators, a nice little unit like this. Um, so the fan unit will go outside. There will be holes drilled through and pipe work. Basically, you have two pipes, one with the fluid going into your house and one with the fluid coming out of your house. And then that goes off to either the fan unit inside or radiators or underfloor heating and hot water cylinder. It's typically permitted development. So that means that you can just go ahead and do it. There are certain rules that your installers will know more about, so it shouldn't be too noisy, too close to neighbors' windows, things like that. But installers know about that kind of stuff, and they will have uh, the ability to do the calculations and make sure that it all meets those needs. You will need building consent, however, if you have a listed building, you're in a conservation area. There's no way around that. Permitted development is outside of conservation areas and non-listed buildings. Historic England are actually given very good guidance on their website. Um, I've kind of felt I've given Historic England a little bit of a bad press in the past because I always thought they were resistant to change, but their guidance has been updated and they do actually try and encourage people living in buildings that are listed or in conservation areas, and they're trying to encourage people to do sympathetic upgrades. And they are happy for heat pumps to be fitted and solar and things like that, provided that it doesn't um, impact the listing. In other words, if it can be hidden away on a roof, something like that, for the heat pump fan, then they're quite happy with that. So you could just put a heat pump on any home, regardless of the insulation level and what the glazing is and all the rest of it. But the greater the heat loss, in other words, how quickly heat goes through your walls, your roof, and every other way, the higher your running costs are going to be. It's a natural consequence of any heating system. If your home is incredibly leaky for the heat, then you're spending more money on your heating costs. So improving insulation and reducing drafts are going to they're going to make your home comfortable, whatever your heating system, but they are particularly useful to do for a heat pump. So I would say if you know you've got issues in your home, if your loft insulation's not um, a good level, or you know you've got drafts coming through windows or under your front door or anything like that, look to tackle that now, because it's going to make your home a better right now, before the heat pump is fitted. And also, if you do that, when the heat pump installer comes out, they will be looking at the level of insulation and the drafts in your home now, and they will estimate the size of the heat pump on that basis. There's no point going, well, I know it's bad at the moment, but after the heat pump's fitted, I'll do a whole bunch of work, because if your heat loss now is made up number 10 kilowatts, and then you do a whole bunch of work and it makes your home so much warmer so that your heat loss is now half that, well, your heat pump is going to be too big. So it's do this first, then get the heat pump. Um, and improve heat emitters. Sorry, that's a jargon. Heat emitters are just where the heat comes from. So for most people, that's going to be radiators. They could be underfloor heating as well. Underfloor heating is a better fit, but obviously, if you've got radiators already, that's fine. You don't need to smash up your ground floor and fit underfloor heating. It honestly is not necessary. Radiators are absolutely fine and can be nice and efficient with a heat pump. And as I said here, heat pumps are most cost effective if the flow temperature, which is the water temperature coming from your heat pump to the radiators, is between 35 and 45 Celsius. Gas boilers typically 60, or as I saw a poor lady this afternoon, set to 75 degrees, which makes the gas boiler, by the way, very inefficient at that setting. But yes, the water will be coming through the radiators or the underfloor heating at a much lower temperature. Now, what that means is less heat will be coming out. So to do the heat effectively, which is still entirely possible, the radiators themselves, the underfloor heating needs to be a larger area. That can be done in a whole bunch of different ways. You can have longer radiators, you can have taller radiators, you can have wider radiators with additional panels, or some combination of all of those. It's all entirely possible. And they don't need to be fancy radiators. They don't need to be vertical ones or anything like that. Typical steel radiators are absolutely fine. Okay, so you're thinking about getting a heat pump, or you have a heat pump. How do you get the most out of it? Well, I would say that a lot of people are running their heating system as a blast in the morning, off they go to work or school, and then blast it again in the evening. Um, and in between, the house gets cold. Heat pumps hate to be run that way. What will happen is if you try and demand a great deal of heat in one go from a heat pump, it's going to work very, very hard and the efficiency will go down. So really what we want to do is run it what's called low and slow. What that means is don't drop the temperature too much. So if you're out during the day, just turn it down. Turn it down to 3 or 4 degrees and then allow it to come back up again. Small variations like that, it means that the heat pump is working much more efficiently and your home doesn't get too cold. It's very much in the sweet spot of the efficiency to run it that way and just drop the temperature overnight or during the day when the home is not occupied by a few degrees. Um, as I said here, typically the heating systems are oversized. So to give you an example, my home, I could, I think my heat loss is something like 5 kilowatts. So I could have a 5 kilowatt heat pump that would heat my house and manage perfectly fine. I had a 12 kilowatt gas boiler that just did the heating. And that's very, very typical. Uh, a heating engineer is going to put in a gas boiler and it's almost they're going to look on what stock they've got and go, that's what we're going to fit. So that is not what you want to do with a heat pump. You will always want it to be at the heat loss area. If you have it too large, it's going to be too inefficient because it will be switching itself on and off. If it's too small, then it won't keep your house warm enough and you'll get cold. So it needs to be sized appropriately for your home. Right. Okay, best tariffs. Well, heat pumps are much more efficient. You know, as we've said, 300 to 400% efficiency. Gas boilers are more like 80 to 90%. So there's a huge increase in efficiency, but we also know that electricity is, just looking at these words again, I think we've lost the letter. I think cancels there. Basically, the higher cost of electricity cancels out most of the efficiency benefits. Um, so you pretty much get about the same cost. We'll go into some numbers shortly. You can, however, choose some clever little tariffs that would help. So there are time of use tariffs, such as Economy 7, where the rate you pay varies through the day. Economy 7 obviously is standard one where it's cheap overnight and then more expensive during the day. Some of the others have 3 rates, where there's a low, a kind of standard, and then there's a more expensive at peak. And I've mentioned here, peak prices can be a lot than standard rates. They're only really worthwhile if most of your electricity usage is not at the more expensive at the peak prices. And there are specific heat pump tariffs. If you can combine your heat pump with solar panels, or particularly with a battery, then what you could do is, if you were using these tariffs, you could shift more of your overall energy usage into these cheaper periods, and that would significantly reduce your heating costs. Again, we'll go into some numbers shortly on that. And here they are. So we've picked an average house that's come off Gem, what they talk of an average house, and we've worked out at the current price cap prices, if your gas boiler is running at 85% efficiency, including the standing charge, that would cost you £955 a year. Oil boilers, I picked the price as at yesterday. That's 855. Typically, people do have additional costs that they have to pay over and above boiler servicing, things like renting oil tanks stuff, but we haven't covered that because that varies. Plus, also the prices since March have varied enormously for oil. So it has been as low as the equivalent of £770 a year. It's also been as high as £1,500. It's rather volatile, and I think we all know why. So currently it looks cheaper than gas, but that could change. And then what I've done is thrown some numbers together here for a heat pump. So again, using the same heat requirement for all of these properties, but using the energy price cap rate, so just the standard electricity price all the way through the day. And I picked 300% efficiency for a heat pump, which is not, it's not an outstanding heat pump. It's a perfectly bog standard heat pump. That comes out at £869 a year. You can see that's slightly less than the gas if you can get rid of your standing charge. In other words, if you get rid of your gas meter when you take out your gas boiler, then at 300% efficiency, that would be cheaper. If, on the other hand, the efficiency of the heat pump can be 350%, you can see that's more than £120 a year cheaper. So that boosting the efficiency of your heat pump as much as you can is a goal for installers and homeowners if possible. So that's the standard tariff. What happens if you pick a heat pump tariff, one that is particular parts of the day where it's cheaper? And I've picked an example here, Cozy Octopus, but there are others. British Gas do one, and I'm sure EDF do, and a few others. Again, you can see that there's a drop here. So we've modeled it as being a 15% drop in energy price if you use Cozy Octopus or other heat pump tariffs. And then if you have a large enough home battery such that all of your energy use, so you pick a heat pump tariff, but you've got a home battery that enables you to charge up that cheaper electricity and then run the heat pump on that stored energy, you effectively can run virtually all your electricity uses off of that cheap rate electricity. And you can see that makes a significant difference. It's about half the price of the standard price cap. You do have to invest in a battery, but that would certainly pay back, very much pay back in the savings per year. Okay, I thought I should talk about other forms of electric heating because heat pumps are not always viable. If you are in a flat or somewhere like that where you cannot have a fan outside, then obviously it's going to be very challenging to go and reach for a heat pump. So you'll end up with having storage heaters or wall-mounted room heaters. Those are infrared panels, and that's just the standard oil-filled radiator. Now, however, any of these direct electric heating will use much more energy than a heat pump because they're all typically 100% efficient, very close to being, it's not quite, it might be 99%, but you basically put 1 unit of electricity in, you get 1 unit of heat out. And they work slightly differently, but pretty much that's the way it works. And of course, a heat pump is more efficient. So aside from storage heaters, the rest are rather more expensive. So I again picked the typical house from the previous one. If you use the same amount of heating, where the previous slide was talking about £950 a year for gas, and 800 nearest well, not £870 on the heat pump, £2,600 on a standard electric heater, just on the standard price. So that's a huge sum. If you have a storage heater that's on approximately half the price overnight, then that would drop your heating requirement to just about half that. So, to be honest, I think it's possible that if you were not able to have a heat pump, you'd be in a smaller property, so your heating requirements would be less. But I just wanted to have the equivalent costs here so that you can see just, some people are stuck and this is the form of electric heating they have. But as much as possible, we're trying to encourage people to use heat pumps just because they are so much more efficient. There's no ifs or buts or maybes about it. I think actually before we go too much further, I appreciate that we'll talk about this in a second. I'm going to hand over to Helen. Now, I appreciate that third heat wave of the year, people are very much looking at air-to-air heat pumps, and they are absolutely viable to both heat and cool your home. The downside to them is that they will only heat the rooms where the units are fitted in. And although you can open doors and things like that, it won't be the same as having radiators in every room. If you ended up having a large enough house and requiring fan units in every room, that's going to make it significantly more expensive and push the costs up much closer to an air-to-water heat pump. Um, you absolutely can do it. I suspect if you tried now, waiting till autumn to get one. Um, uh, but yeah, I just thought I should mention. I know we talked about the fact that they don't do hot water, um, and I would put my hand up here and say that's the heating system of my house. It's air conditioning units. I have two fans, and there are three units in the major rooms, the living room downstairs and the two main bedrooms, but it's not for everyone. Um, you do get air moving, whether it's cooling or heating. Not everybody is happy with those kind of drafts. So, just kind of be aware of that. I'm not trying to put anybody off, but it's something to think about. If you want it just for cooling, that's one thing. But if you are looking to replace your heating system, you do kind of have to consider that there are pros and cons there. Okay, Helen, do you want to take this page, or do you want me to do the install a bit?
Hello, no, I will. If you just bear with me. I've got to put myself back on Spotlight and I can't remember how to do it.
Oh, sorry.
So maybe you should, because I can't put myself back on Spotlight. Yeah,
I
do you
just
mind
tried.
covering that?
Okay, I think I just tried putting you on Spotlight,
Oh,
but
someone has. That's probably Gabriel in the background. Okay. So yeah, could you move the slide on,
okay, you want the next one rather than the installer one.
please?
Okay,
Oh, sorry.
I thought you were
Which
going to do
one?
the installer one.
Yeah, I will. Yeah. Okay. So the first thing, which Martin talks about a lot, is to make sure it's registered with the trade body. What does MCS stand for, Martin?
It's the
Mike.
yeah, micro generation certification scheme.
Yeah. So that's really important because that's the only way you'll be able to have any form of redress. They also have a list of registered installers, so you get a certain amount of quality by doing that. And it's worth mentioning for solar, it's also the only way that you can feed and sell back um, into the grid. So I thought I'd just mention that. So the other key thing when you're looking for an installer is ask about after sales support and the length of warranties and so on, because they can vary a fair amount and the price of that, and ask for that price to be separated in your quote. Um, some of them are much more generous than others, and it's part of the whole picture. You can carefully compare quotes at all. Of course, we recommend getting at least three, and Martin does offer a service where he can have a look over them with you. So if one's markedly different, or um, they're suggesting a different layout to where you might have the various pieces of kit, that's really important to get some insight from Martin and so on. And if the heat loss calculations vary, because that's the absolute crucial part to any heat pump installation, that could be a sign that things aren't quite right. Martin was telling me that sometimes he visits people who are just a little bit disappointed in their heat pumps. And I think at least once he's come across a situation where it was wrongly sized. So that
It's
support that you
very
can have
common.
from him
Yeah.
at that stage could be really valuable. And then finally, beware of wild claims. You might see an advert maybe on Facebook which talks about, save thousands of pounds a year, when you're maybe only paying £1,000 anyway. Um, we don't come across any, as far as I know, any actual scams in the local area. We don't have any direct concerns about any local installers, um, but sometimes it may not be the right one for you. My general rule is if I want something, I'll go and find it. I won't passively react to any hard selling or so on. So I think that principle applies. There are scams and falsehoods presented online. Sometimes you'll see an advert saying, free finance, or rather free heat pump or whatever. And of course, usually it's a finance agreement that's being offered to you at much higher rates than you would normally have. So in a help sheet, which we're going to give you a link to at the end, We do have a list of local installers. We're not recommending them. We've just got no specific reason to think there are any issues with them. It's just to help you get started on a local installer. And Martin does recommend choosing a local person because any follow-up or problem solving afterwards is easier than trying to get someone back down from the Midlands or something. So that help sheet should be useful for you. Could I have the next slide, Martin? So funding and finance, Martin's already explained the heat pump grant, which is actually called the Boiler Upgrade Scheme. You'll find it on gov.uk. It's very easy to find the information, but it's a confusing name, Boiler Upgrade Scheme, isn't it? Because it sounds like it's for a new boiler. But anyway, that's all on gov.uk. There's also, you might have heard of Eco4 or EcoFlex, which was the last big grant scheme, which did sort of a whole house retrofit for eligible people. That's now finished towards in all intents and purposes. And there is a new thing called the Warm Homes Local Grant, which was announced last year and is underway in East Sussex. That has certain eligibility criteria, income-based eligibility criteria. The income threshold is household income of less than 36,000. So it's not as low a threshold as you might expect. The only thing on that is that we understand that all the allocations for work have actually already been granted. So if you were to apply for that, you'd really just be being added to a waiting list. But it's really probably still worth you doing that if you're eligible, because you'll see at the bottom there's another grant coming in 2027. It's been announced, but we don't know the details yet, called the Warm Homes Local Plan. So everything warm homes and local is good. That will be free installations for people on low income. So not just heat pumps we're talking about here, we're talking about house retrofit, including insulation, possibly solar, and low or zero interest loans for others. So I'd say if you think you're eligible for the Warm Homes Local Grant, apply. It's very easy to do on gov.uk, and you'll be added to a list and something may well come of it, or it may well not. So that's the two things really, the boiler upgrade scheme, which is the heat pump, and the Warm Homes Local Grant. In terms of financing, you might be thinking, oh, I'll just wait for this Warm Homes Local Plan thing and see if I can get a low interest loan. You could do that. Installer companies do sometimes offer financing or subscriptions. You'd need to look very carefully to see if that was a good loan, a value for money loan, because sometimes they're, over and above what you'd pay for a standard bank loan or home improvement loan. You can get ethical loans from some places like the Parity Trust, and they offer some flexible terms if you run into difficulty or so on. You can also extend your mortgage, of course, that old chestnut. And some mortgage providers also offer incentives, like £2,000 towards a heat pump or solar or something. They'll often require that you use their partner installer. So that may not end up being as good a deal as it might look initial, but it's all options, and the mortgage provider would want to do a good job, I guess, so as not to get bad press. So there's some various funding or grants options. Do make sure you're on our mailing list for Energise Sussex Coast, because as things unfold with the next scheme, the Warm Homes Local Plan, we'll be making sure everybody knows about the details of that. And do give us a call if you'd like any advice on grants or finance. Okay, so as we've been talking, thank you very much, Martin. That was really, really straightforward, I think. I hope that's all been good for everybody. There's a good number of questions in the chat, which I'm going to present to Martin. We're going well for time, but let's see how long it takes. As I said earlier, if there are any questions that aren't covered, we'll get the answers to you afterwards. So I think I might just take them in the order they came, because why not? So let me just get back to the beginning. Okay, so the first question is around air to water pumps that also do cooling. So that was one question. And then another participant said that they'd recently seen Octopus R&D Labs are working on an update to their Cozy heat pump, which uses the radiator circuit to extract heat from an air conditioner unit. Do you know anything about that?
I haven't heard about the cozy side of things. I've certainly heard about um, yeah, schemes that or systems that could do that. Um, my understanding was that it does require very careful design, and I'm not sure that all the kind of standard manufacturers of um, air to water heat pumps, whether their standard models will do that. I know that air to air are very typical, that they're reversible, but um, yeah, I certainly I had a talk I was doing several months ago, and someone said, "Oh yeah, they had much more knowledge about it, and they were talking about it and saying, oh, you have to be very careful about the dew point, basically where condensation forms." Um, so I did mention that a little bit in the earlier section. So I've heard of them. I would say if that's it's worth exploring with an installer. I don't know too much about it, and it's on my action plan of find out more about it. So I'll probably go off and we may well add that to the FAQs. It's one of
Mm.
those. I know it exists as a concept, but I don't know how easy it is because if you would struggle to find a model of air to water heat pump in the UK that does that, it's a bit hard to then say to your preferred installer, can you fit this if they've never done it before? Because then it's a little bit too much like they're experimenting on your home. If they were experienced, that's fine. But I absolutely. I think more and more people will be looking at that, but I don't know enough about it myself, so
Yeah,
it's on
yeah.
my homework list.
A lot of
So
this is very new, isn't it? And it's hard to trust things that are very new. So another thing related to cooling, a participant is asking whether ground source heat pumps can do passive or active cooling. I don't know what that means, but you might.
um, well, I mean, I think passive. I guess it very much depends what you've got. So if you have an air source heat pump, sorry, a ground source heat pump, anything that's got underfloor heating, you have a great deal of thermal mass in the floor. Um, so there's the water pipes, but there's also typically a concrete floor. Um, and I would say that that will make the rooms harder to overheat. It's not impossible. Don't get me wrong, it absolutely can overheat, but it makes it harder. If you have any system which can extract heat from that and stop it overheating, whether that's a ground source heat pump or an air source heat pump, working in that kind of opposite direction, that will help keep surface that floor cooler temperature. I don't know about radiators, whether that's as easy. So like I said, it kind of plays into the previous question of um, I don't know enough about it. I think in theory it could, but again, I don't know enough about it to be able to say whether they could or not. And again, it would it again with a similar point to the air source heat pump, you'd need a pump that would actually be able to work the opposite way because some of them are set up much like air conditioning units. Some air conditioning units are set to do cooling, so they're intended to extract heat, and blow cold air into your living room. Um, you can get plenty that do it the other way, but if you've got a dedicated model that only does cooling, um, obviously that's not going to be able to do heating. Likewise, if you've got any kind of a heat pump that's doing fluid inside, so radiators or underfloor heating, and it's intended to heat, it will not be able to work the other way. If it's able to do both, then I guess with correct design, it could do it. Um, yeah, again, my homework list.
It sounds like there's a good role for us as we find out about these things to include it in our newsletter, little updates
Yes,
about those bits of tech and stuff. So
definitely.
that's something we'll try and take forward. Another question about choosing the right kit. There's someone who's concerned about corrosion of the fan unit in the salty air in our area. and they know of heat pumps in their village where they're corroded away in a few years. And do you have any data or knowledge about that, whether warranties are affected or implicated in any way, the salty air?
Yeah, it's yeah, I don't have any direct knowledge of that. I mean, I have fan units outside. The oldest fan unit I've got was put in 2019, so it's now 7 years old. And I'm relatively close to the coast. I'm only in Hastings, um, about 100 meters from the coast. Um, there's not been any corrosion on mine, but that's obviously not the same for everyone. I think if you were very exposed, um, in theory, heat pumps should stand up to anything. The warranties are usually, depending on how your installer is accredited, but they can be anything up to 7 year warranties for heat pumps. They will need annual servicing to keep that current. Um,
Mm.
so I would say that it's likely that would cover corrosion because they will have, um, it will be stainless steel and things like that. They're
Mm.
intended to be outside. They're intended to stand up to whatever conditions. But
Yeah,
um,
it might be possibly
it's
just
hard to
this
know.
experience of some having corroded. Possibly they're the older models. Again, we could maybe look
It's
into
hard to
this
know. Yeah,
and let people know, any particular implications. I
sure.
imagine that a warranty wouldn't be granted on the same terms if there was any significant problem, um, because
It's
they're
hard
going to
to
be
know.
very risk averse, aren't they, when issuing the warranty? But that's a very interesting one. We need to be sure, don't we?
Yes, I'll need to check into
So
that.
let me just see. Um, what's the best tariff if you have solar and a battery, a couple of EVs, and a heat pump? The full works. And they're saying that most tariffs
Right.
seem to be focused to one of those technologies rather than all three.
Definitely. So it very much, I would say, until you added the heat pump into the mix, I would have said going for an electric car charging tariff would have been the cheapest. You get very cheap overnight electricity, much cheaper than heat pump tariffs. Um, but that is very much tends to be about midnight till 6 or 7 in the morning, something like that. That doesn't work well for a heat pump because your heat pump needs to be on virtually all day, if not all day. You can turn it up and down. Um, Heat pump tariffs, on the other hand, tend to have anything up to three um, cheaper periods through the day. So there'll be one in the morning, one in the afternoon, one in the evening. Some of them are two, but mostly they're three. A relatively small battery lets you bridge the gaps there. So you could, I was looking, actually doing some calculations earlier. If you had a typical, say, an 8 kilowatt heat pump, very typical for semi-detached houses, um, then I think a battery of about 8 kilowatt hours, which is about standard for people getting solar, maybe a little small. That would be enough to bridge all the gaps. That would not be enough if you had an overnight cheap electricity tariff like an electric vehicle charging one. So it very much comes down to you either end up with a big battery or you pick the one that is your most electricity usage. And so if your electric cars are needing to drive, I don't know, 400 miles a week, then chances are the electricity from that is going to be a big portion of your
Mm.
annual usage,
Mm.
potentially more than your heat pump. So it might actually be better to focus on an electric vehicle charging tariff and then see about um, up, potentially increasing the size of your home battery to um, reduce the heating costs. If, on the other
So
hand,
that
your electric
sounds,
vehicles are quite small usage, then I would focus on the heat pump usage and go for a heat pump tariff.
it
It very
sounds like
much is down
something,
to individual kind of, I need to know what
yeah,
your numbers are to then
yeah,
be able to sort of advise you
yeah.
appropriately. I don't think
So
it's one
Martin could
size.
offer some personalised advice to help you maybe try and unpick those tariffs. It's kind of easier to do together sometimes, isn't it? So a
Yeah, I
couple
mean,
of other,
sorry.
sorry. we're probably best
No,
just cover these
yeah,
last
yeah. Let's
questions.
move on. Yeah,
So,
sure.
with air to air, where you've got the fan in each room, how many units would you recommend upstairs? Every bedroom and the bathroom, or question mark?
I would say usually it's not a good idea to fit them in the bathroom. Um, I did look at it for my house. Um, there is worries about exactly how well they'll work with the damp air in the bathroom. Um, and so generally it's not advised to put them into a wet room. So kitchens or bathrooms, generally not. So I would say at least the major bedrooms. So if you had a three bedrooms, but one of them's a box room, you don't really use it, maybe you don't need to do it for that. But I would say pick the main bedrooms and at least the living area. Um, those are the areas you're going to be in most. The bedrooms, because you're going to be sleeping in them and you really want the cooling, I would suggest this time of year, at the moment, for most people, that's going to make a huge difference.
Mm.
And living area, which is where you're going to be during the day or in the evening before you go to bed. So I would say pick those are the three main areas, the two main areas, the major bedrooms and the um, living area would be kind of, and if you've got open plan spaces, that works better for air to air. Because
Mm.
actually a single unit could cool most of your ground floor if it's open plan. You wouldn't need major ones because a lot of them can actually um, move the airflow around. They've got vanes and they can actually direct it. They can be moving around so they can sh shift the air to different parts of the room.
Mm.
Um,
So,
so yeah,
supplementary question: does that also mean not the kitchen, or would it depend on the size of the kitchen, whether it was open plan and so on?
I mean, if the kitchen's part of your open plan downstairs, then it would just be included. I would say again, yeah, not in the kitchen. I appreciate that that might mean your kitchen gets hot, but frankly, your kitchen is probably going to get hot because you've got the cooker on and things like that. Um, what you can do, and I'm guilty or not guilty, I've used this, is put a fan in, say, the doorway of the kitchen. So if it's cool somewhere else, you could put a fan there and direct cool air from another room into a hotter room and without having to fit an air conditioning unit there. But I would again say it's it's not advised to fit an air
Yeah,
conditioning unit in a kitchen
this
just because
person is
you're going to
just
get,
thinking,
yeah, the filters are going to get
yeah,
clogged with all kinds of stuff
right.
from the cooking.
So this
Uh,
person's just thinking, well, how do I heat the kitchen if that's the case? So it's a bit of
but
a challenge there potentially.
yeah, I mean, if you can have doors open, the air will naturally move from rooms to room. Even a fan, when you're heating, the fan will just move the air. So you could again just shift the air using a fan.
So it might
A
come
larger
down
fan.
to your insulation and your draft proofing a little, so
Yes.
that you're not losing heat
I
in
mean,
inappropriate places.
yes. So also what you're going to do, if you heat one room, heat is naturally going to go through the walls to adjoining rooms, even without the doors being open. If you heat a living room and the kitchen has got an adjoining, some of that heat will come through. It will not be an unheated space. So that might be adequate. Um, again, you'll have to kind of decide that on for yourself, really.
Mm. Hey, there was one question around ventilation, so really about retrofit in general, that you have to get whenever you're retrofitting a house, you have
Mm.
to use the correct ventilation to avoid condensation. Are there any heat pump related aspects that people should know about ventilation?
I, I suppose in some ways, yes. I mean, heat pumps aren't going to make things. I suppose if you had an air to air, so if you've got air conditioning units and you're running it in summertime, in fact, even in wintertime, what will happen is you will get some drying of the air, a small amount. It's not a huge amount, but they will need to drain. So you'll get some condensate and it will need to be drained outside. So if whatever kind of heat pump you've got, you run the risk of that. So if you've got a fan outside, what you can't do is just put it straight onto a patio. It needs to drain away that. So in other words, if you get ice build up on the fans, that can melt. You don't want that on your patio to slip on it. But also, if you are running an air conditioning unit, you will dry the air very slightly. It's not a major part of it. You can run a cycle with most air conditioning units, so air to air, where you can dry the air out, but then it won't do the cooling. When you are cooling, it will dry the air out very slightly. Um, if it does get too dry, that could be bad for people's um, mucus. Sorry, I was going to go into too much detail, but your lungs and your throat could dry. If it dries out too much, that's not so good for your health. Same way that, in a different way, that damp is too bad. If it gets very dry, that can be bad as well. So, but ventilation wise, I would say if you've got fan units inside, it's naturally going to move air around the home. Um, and what that will mean is that you're less likely to have condensation and mold forming just because the air is moving, which you won't get if you've got radiators or underfloor heating.
Mm.
Ventilation is still a very, very good thing to have in any house, whatever it is, whether you've got solid walls, cavity walls, whatever. Having extractor fans in the kitchen and the bathroom in particular is, I think, necessary for most homes, if not all homes. Um,
Mm.
so I just think whether you've got a heat pump or not, I think probably most people are overlooking ventilation anyway. So I'm
Mm.
not sure if that
Thank
answers
you.
it, but that's my opinion on it.
So we've only got time for one more quick question. And while you're answering that, I'm going to put a few links in the chat around how to contact Martin for some energy advice, some help sheets about heat pumps, bits about the grants and so on as well. So please do. We'll also send this in a follow-up email. So the last question, I do apologise. I think there's one or two we haven't covered. So we will try and send you the answers, or do email in if you've got a straggly question that we haven't answered. So this last question is, how far from property boundary and or neighbour windows should the outdoor fan unit be installed?
Okay, until recently, you had to have it within a meter from your boundary. So that was very difficult for flats. Permitted development rules have been changed so that it is, they've removed that ruling. So you can now have the unit much closer. As to where the fan unit can be sited, there are very strict rules under the MCS accreditation on the noise level. So every installer will be required to work out the exact level of decibels of the noise from a fan unit at a neighbour's window, multiple windows. So they will have to calculate that. And only if it falls below a threshold, I don't remember what the threshold is. I have it in my head, it's 38 decibels. Yes. I think it used to be 40, so they've actually downgraded it to 38. But what's required is, so if you had a fan unit on your wall directly facing a neighbour's window that was only 2 meters away, it's unlikely to meet the MCS requirement for the noise level. It's likely to be too high. So they would, at that point, need to come up with some other method, whether that's move the fan unit somewhere else, point it in a different direction, however it is. Uh, site it somewhere where there isn't a neighbour's window directly facing it. And there are all kinds of mitigations around if there's a wall partially blocking it or totally blocking it and all the rest of it. Um, so I think for most people, if it's an adjoining neighbour, semi-detached house, and it's on your a back wall or even a front wall, that's unlikely to cause issues with the noise. But yeah, if it's on your side wall facing a neighbour, then that might be more problematic depending on where their windows or their back door is or something like that. But like I said, the installers will handle with that. Um, if anyone who's fascinated enough to look, MCS does have all of this on their website. I have spent many a happy hour, or at least some hours on it, doing calculations for people. So, including for my own home, just to try it out. So yeah, like I said, they will cover all of that. But yeah, it is slightly easier with where you can position the units now because you don't have to worry about how close it is to the boundary. But yeah, there's still the noise one, which is good. I just feel bad that the noise level that has been picked is significantly less than gas boilers and oil boilers. The flues on those are extremely noisy, but there's no rules around that. But there is on heat pumps. But there you go.
Great, thank you. I think that's the first time we've done one of these talks and we haven't had the noise question. So I'm very glad you got the chance to cover that at the end. So thank you very much, Martin. If anyone would like either just one specific query or even if you'd like a home visit to really look into one aspect of, a heat pump or solar or anything like that, please do contact us. Thank you very much for coming.
Thank you, everyone.